Alright guys, so this is the last section in chapter 7, and what we're going to be doing today is we're going to be solving equations with rational expressions. This is probably the most important section besides 7.3 because this is something that you're going to have to know how to do when you get to college algebra. So, an expression versus an equation. And expressions do not have an equal sign. Okay, so this is exactly what we've been doing in section 7.1 all the way to 7.5. So what we've been doing so far has been dealing with expressions. And all we can do with an expression is we can simplify. Okay, and I'll show you on the next slide some examples of that. Equations do have an equal sign. And whenever you do have an equal sign, what you have to do for your instructions is you have to solve it. Meaning you have to get the variable equal to some type of number. And typically, you're going to get 1 to 2 answers. If it's linear, that means, if it's linear, then that means you'll have one solution. If it's a quadratic, meaning x squared, and then you have to use your factoring as fun worksheet to be able to solve it, then you'll have 2 solutions. Okay? So, the first part of your homework, what you're going to have to do is you're going to have to identify each of the following as an expression or an equation. Then simplify if it's an expression or solve if it's an equation. So, we've got 4 over 7x plus 4 over 5x. With reading that problem, you see that there's no equal sign. So, because there's no equal sign, we call this an expression. So, all we can do is, with an expression, is we can simplify. Okay? So, we've got fractions. Whenever we have fractions, we got to make sure the denominators are the same. 7 and 5 are not the same, so my LCD would be 35. So 7 times what will get me to 35? That would be 5. So if we do it to the bottom, we have to do it to the top. So 5 times 4 is going to be 20 over 35x plus 5 times what gets me to 35? That would be 7. So 4 times 7 is going to give me 28 over 35x. Now my LCD, or my denominators are the same, so I can keep that denominator. My variables are the same, or the terms are the same, so I keep that x. And then 20 plus 28 is going to be 48. The last thing I have to check, since it's a fraction, is that can I simplify this? And no, you cannot. So this is as simplified as it possibly can be. Alright, let's look at the next one. So we have 3 over 5x minus 7 over 10x equals 1. Alright, so for this one, we see an equal sign. And whenever we see an equal sign, we want to call that an equation. And I do expect you to tell me on your homework for the first couple if it's an expression or an equation. So we have 3 over 5x minus 7 over 10x equals 1. Alright, so again, when we add fractions, we have to make sure and have the same denominator, which it's not, so we have to figure out what our LCD is. For 5 and 10, our LCD is going to be 10, so we only need to change the first one. 5 times what gets me to 10? That would be 2. What I do to the bottom, I have to do to the top. So I got 6 over 10x minus 7 over 10x equals 1. Because my terms are exactly the same, my denominators are the same, I keep that denominator of 10. X, and I go 6 minus 7, which would give me a negative 1, equals 1. And my goal, remember, for an equation is to solve it. So I've got to get x by itself. This is linear because it's just an x. So what I need to do now is I need to multiply by the reciprocal. But what I do to one side, I have to make sure and do to the other side. So the reciprocal would be negative 10 over 1, which is just really negative 10. So then I cross cancel, my negatives cancel out, and I'm just left with x on the left. And then 1 times negative 10 is going to be negative 10 as my solution. So x equals negative 10. So that is the difference between an expression and an equation. And you need to be able to do those two. Alright, so this is the most important slide for this section. And what you need to do is you need to know how to solve equations with rational expressions. Okay, so step 1. You have to determine where the rational expression is going to be undefined. So what you do is you set whatever the factor is which is whatever is included with the variable, and you set it not equal to 0. So like if you had the variable x plus 2 cannot equal 0, then what you would do is you would subtract the 2 on both sides, and you get x cannot equal -2. We did this in section 7.1. Alright, step 2, you have to find the LCD for all rational expressions. Remember, to find the LCD, first thing you do is you factor, then you ask how many are in each factor, and then step 3 is you multiply the maxes. Okay, and that's how you find your LCD. Step 3 is so important. What you do is you multiply each rational expression by the LCD. So you write out the LCD beside each rational expression and cancel out the things that are in common between the denominator and the LCD. What this does is it gets rid of the denominator. Okay, so it's a tedious step, but it really helps. And then the last thing you have to do is you have to solve the equation that is left. So you're trying to get x equal to some type of number. Sometimes you'll have 2, or x equals some type of other number if it is a quadratic. Alright, and the last thing you have to do is ask, does this solution work? And the way that you figure this out, if you have x equals some type of number and it doesn't equal up here, so as long as if I get an answer and it doesn't equal -2, the solution absolutely works. If it does equal -2 when I solve, then what that means is that there's no solution. Alright, so let's make it real. So we've got x over 2 minus x over 3 equals 5 over 6. The first thing that I notice is that I have an equation, so what I have to do is I have to solve it. So what we have to do first in step 1 is to determine when the rational expression is undefined. So what we do is we look at our denominators, because we don't want to have a 0 in the denominator. But if I look at the 2, the 3, and the 6, there's no variables for that. So since there's no variables in my denominator, my answer is going to be all real numbers. Now, if you want to put it as the symbol notation, it's just parallel lines with little fancy r. But it's all real numbers. Either way is totally fine, but I need to see this step. A lot of people don't do this step. Alright, step 2, we have to find our LCD. Alright, and so we have 2, 3, and 6. So in order for 2, 3, and 6, our LCD is going to be 6. Alright. And if you need to, you can do the factors. So we have a factor of 2, a factor of 3, and we've got 2, 3, 6, and then we could put the max. Alright, so in 2, how many 2's do we see? That would be 1, 0, 0. For 3, we have 0, 1, I'm sorry, that should be 1. For 3 we have 0, 1, 1, so my max would be 1, and my max would be 1, so 2 times 3 would give me 6, if you need to see that. I don't have to see this. If you just tell me what your LCD is, I'm good to go. Alright, step 3 is you have to multiply each rational expression by the LCD. So you have to go 6 times my first term, which is x over 2, minus 6 times x over 3, equals 6 times 5 over 6. This is going to definitely take time, which is a-okay. So now what we got to do is we got to clean this up. So what I'm going to do is I'm going to put a 1 over my LCD, because now I have fractions, and when I multiply fractions I can cross cancel to simplify. So I would do the 6 and the 2. 2 can go into both, so that's going to leave me with 1 and 3. So I'll be left with 3 times x, so that's 3x. Then 6 and 3 cancel out, 1 and 2, so I've got minus 2x, because 2 times x. Then right here the 6's cancel out, so I'm just left with 1 times 5, which equals 5. Now this linear equation is a heck of a lot easier for us to be able to solve it. So I go 3x minus 2x, which would be x equals 5. And then the last thing I have to do is I have to say, does this solution make sense? X equals 5, it's all real numbers, so absolutely this makes sense. And that's how I solve equations with irrational expressions. Okay, let's try another one together. So I got 1 minus 2 over x plus 1 equals 2x over x plus 1. So first thing I have to do is I have to figure out where my rational expression is undefined, so I'm going to put this over 1. So what that means is in my denominators I see variables, so I have to set that factor not equal to 0, because it cannot equal 0. It can equal anything else besides 0 because we don't want it to be undefined. So what I do is I subtract 1 on both sides. So I got x cannot equal negative 1. So if I get any other answer besides negative 1, I have a solution. But if I get in step 4 and my x equals negative 1, then that means there's no solution. Alright, step 2, I have to find my LCD. So if I'm looking at my LCD, I've got 1, x plus 1, x plus 1. So my LCD is just going to be x plus 1. Then step 3, this is the tedious step. I have to take my LCD and I have to multiply it by each term. So I go x plus 1 times 1 minus x plus 1 times 2 over x plus 1. And it might be easier to keep that in parentheses. Equals x plus 1 times 2x over x plus 1. Now again, I'm going to put a 1 underneath each rational expression, except for the first one. That's not really necessary. Just so I can see what I can cancel out. Well, 1 times x plus 1 is just going to be x plus 1. The x plus 1's here cancel out, so I'm just left with minus 2 equals. The x plus 1's cancel out again, so I'm going to just be left with 2x. So now I have a linear equation of x plus 1 minus 2 equals 2x. So what I do is I combine my like terms, so I got x minus 1 equals 2x. I subtract x on both sides, so I got negative 1 equals x. Now I have to ask, does this solution make sense? Well, I got my x to equal negative 1. Are we allowed to have x equaling to negative 1? Absolutely not. So what this means is we would cross it out, and we'd either put no solution, or you could put empty set, because there's no answer that will work, or you can put the symbol notation for empty set, which is just a 0 with a diagonal line through it. I don't care. Either one of those three, 100% correct, but I do need to see this work. So if this number matches your step 1, then that means that you have no solution or an empty set. Okay, so let's try another one. If I've got 7 minus 2x over x equals negative 17 over 5, first thing that I want to do is I want to figure out where it's undefined, so I just look at my denominators and I set whatever the factor is, so x cannot equal 0. And I don't have to solve anything, so as long as I don't get x equaling 0, I'll be good to go. Alright, step 2, I have to find my LCD. Again, I'm just looking at my denominator, so I have x and I have 5. So my LCD is going to be 5x. Then I take my LCD and I multiply it by each term. So I would go 5x times 7 minus 2x over x equals 5x times negative 17 over 5. Then I'm going to take the rational expressions and I'm going to put a 1 underneath it to create it to be a fraction so it can clean up really nice. So when I cross cancel, the x's will cancel out, so I'll be left with 5 times 7 minus 2x equals, this time the 5's will cancel out, and I'll be left with negative 17x. Alright, so the next thing that I do after this is I'm just going to clean it up. So we're going to distribute this 5 to both terms, so 5 times 7 is 35, minus 10x equals negative 17x. Next thing I'm going to do is I'm going to bring this 10x over, so I'm going to add 10x on both sides. So I get 35 equals negative 7x. And then the last thing I'm going to do is I'm going to divide by negative 7. So So I get x equaling -5. Last thing I have to do is I have to ask myself, hey, does this answer make sense? And I look at step 1, and as long as x doesn't equal 0, which x does not equal 0, it equals -5. Therefore, this is my answer. This process is definitely tedious, but hopefully you don't feel like it's too hard. Alright, so here we go. I took away the steps this time, but we're going to still work through them. So we got 8r over 4r squared minus 1 equals 3 over r squared plus 1 plus 3 over r squared minus 1. So first thing I have to do is I have to figure out where it's undefined. Now before I can find out where it's undefined, I sometimes have to factor, and this right here is definitely factorable. When I have two terms, it either can be a GCF or it can be a difference of a perfect square. This one is a difference of a perfect square, so I take the square root of 4r squared, which is 2r. Then I take the square root of 1, which is going to be 1. So I set up my binomials, and I go plus minus, so 2r plus 1, 2r minus 1. Okay? So now I can do step 1, and I have to figure out where it's undefined. So I take each factor that's different, and I set it not equal to 0. So I've got 2r plus 1, and then I got 2r minus 1 cannot equal 0. And now what I have to do is I just have to solve for r. So for this first one, I'll subtract 1 on both sides. So I've got 2r cannot equal -1. Then I divide by 2. So I get r cannot equal -1/2. Right here, I'm going to add 1 on both sides. So I get 2r cannot equal +1. Then I'm going to divide by 2. And r cannot equal +1/2. Okay, so this was step 1. So as long as it doesn't equal positive or -1/2, you're going to be good to go. Alright, step 2. So we have to figure out what our LCD is. So LCD is going to be 2r plus 1 times 2r minus 1. Okay, and their max is just 1, so you can just write it out. Step 3, so this is step 2. Step 3, we have to write our LCD times each term. So this takes time. So write this out. So we go 2r plus 1 times 2r minus 1 times 8r, and I'm going to write it in factor form so it's easier to see. 2r plus 1, 2r minus 1 equals, write my LCD again. So 2r plus 1, 2r minus 1 times my next term, which is 3 over 2r plus 1 plus 2r plus 1 times 2r minus 1 times 3 over 2r minus 1. Okay, and I'm going to put my rational expressions over 1 so I can cross cancel easily. Give you a second to copy that down. Okay, so now we're going to look to cross cancel. So if I'm just looking at these two rational expressions, I see that the r plus 1, or I'm sorry, 2r plus 1s cancel out and the 2r minus 1s cancel out, which would just leave me with 8r. For the second rational expression, I see the 2r plus 1s cancel out, which I would be left with 3 times 2r minus 1. And then for the last one, 2r minus 1 cancel out, and I'd go plus 3 times 2r plus 1. Okay, so now all I gotta do is I've got to solve this. So I'm going to distribute the 3 to both parts. So I've got 8r equals 6r minus 3 plus 6r plus 3. Alright, so I'm almost there. So when I clean this up a little bit more, I see that the 3's go away, and I'm left with 8r equals 6 plus 6, which is 12r. Then I'm going to subtract the 8r on both sides. So I'm left with 0 equals 4r. I'm going to divide both sides by 4. And I'm going to get 0 equals r. Because remember the OK and the no, as long as the 0 is up in the top, it's absolutely okay. So my final answer is going to be 0 equals r. Last thing I have to do is I have to check, does this make sense? Well, it doesn't equal negative or positive 1/2, so absolutely this answer is completely fine. Alright. Now what we're going to do is we're going to deal with some tricky problems. The reason why these are trickier problems is because instead of it being a linear equation when you solve, it's going to end up being a quadratic, but it shouldn't be too bad. So we have x over x minus 3 plus 4 over x plus 3 equals 18 over x squared minus 9. So the first thing that we want to do is we want to figure out where it's undefined, but before we can do that, we need to factor this right here. So if it's two terms, it's either going to be a GCF or it's going to be a difference of perfect squares. This one is a difference of perfect squares, so I take the square root of x squared, which is x, take the square root of 9, which is 3. I set up my parentheses, plus, minus, x plus 3, x minus 3. So for step 1, to find out where it's undefined, I go x minus 3 cannot equal 0. And I take the other factor that's there, which is x plus 3, cannot equal 0. And you just have to cover it one time. So right here, I'm going to add 3 on both sides. So I get x cannot equal a positive 3. I'm going to subtract 3 on this second equation, and x cannot equal negative 3. So as long as x doesn't equal positive 3 or x doesn't equal negative 3, any other solution will completely work. Next thing I got to do is I got to figure out my LCD. So my LCD is going to be x plus 3 and then x minus 3 because my maxes are just 1. And step 3 is the tedious step. We have to take our LCD and we have to multiply it by each term. So we would go x plus 3 times x minus 3 times x over x minus 3 plus x plus 3, x minus 3 times 4 over x plus 3 equals x plus 3, x minus 3 over 18. And again, I'm going to put it as factored form. So I'm going to go x plus 3, x minus 3. And then I'm going to take each LCD, I'm going to put it over 1. Give you a second to copy that down. Okay, now I'm going to look to cross cancel. When I look at these two rational expressions, what I can cross cancel is the x minus 3. So I'm left with x times x plus 3. When I look at my second group, the x plus 3's cancel out. So I'm left with plus 4 times x minus 3. And then when I look at my last group, the x plus 3's cancel out and the x minus 3's cancel out. So I get equals 18. Okay, now I've just got to solve this. So in order to solve, I've got to distribute the x, I've got to distribute the 4. So x times x is x squared plus 3x plus 4 times x is 4x minus 12 equals 18. Alright, combine our like terms, so we got x squared plus 7x minus 12 equals 18. Alright. Now this brings us back to section 6.5 where we're having to solve, so we have to get one side equal to 0, so I'm going to subtract the 18 on both sides. So I get x squared plus 7x minus 30 equals 0. So now I can solve it. I see that I have three terms, so it's either a equals 1, a does not equal 1, or it's a perfect square trinomial. This one is a equals 1. So I set up my two binomials. I go x plus minus, so it's going to be plus minus factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. I have to use subtraction in order to get to a positive 7. So I'm going to use the 10 and the 3. My 10 has to be positive, my 3 has to be negative, because 10 minus 3 gets me to 7. Then the next thing that I do is I split them up, so x plus 10 equals 0, x minus 3 equals 0. I subtract 10 for my first equation, so x equals negative 10. I add 3 on both sides for my second, and x equals positive 3. So now the last thing I have to do is, does this make sense? So as long as it doesn't equal a positive 3 or a negative 3, you're good to go. So this x equaling negative 10 is awesome. But this x equaling 3 cannot work. Okay, so when we have one solution that works but the other does not, you just cross out. Because we do get a solution, so no solution would not be a sufficient answer. So you need to make sure and box the one that makes sense. But if you forgot to do step 1, you wouldn't have thought to check it. So please don't forget to do step 1 where you determine where it's undefined. Okay? So now I want you to try. So pause this for a second and I want you to give it a go. And actually, it should be like this. So pause it for just a second and I want you to try, please. Okay, so I've got 2 over p plus 3 plus 3 over 8 equals 5 over 4p plus 12. So first thing that I got to do is I have to figure out where it's undefined. Before I can do that, I have to factor this last one. So I got 4p plus 12. That's going to be a GCF. So I can pull out a 4. When I pull out a 4, I got p plus 3. Okay, so my equation that I can set not equal to 0 needs to be p plus 3 cannot equal 0. So the next thing that I do is I subtract 3 from both sides, so p cannot equal negative 3. So if I get any other answer besides p equaling negative 3, I'm good as gold. Step 2, you have to figure out what our LCD is. Okay, so I definitely have the p plus 3 in there, but now I've got a 4 and I've got an 8. So my LCD of 4 and 8 is going to be 8. Okay, so I take my LCD and I multiply it by each term. So I'm going to go 8 times p plus 3 times 2 over p plus 3 plus 8p plus 3 times 3 over 8 equals 8 times p plus 3 times 5 over, and I'm going to clean it up, 4 times p plus 3. And then I'm going to take my LCD, I'm going to put a 1 underneath it to help me with cross canceling. Alright, next one, cross cancel. The p plus 3's from my first rational expression will cancel out. So I've got 2 times 8, which will be 16. So 2 times 8, 16. My 8's cancel out, so I'm going to be left with plus 3 times p plus 3. And then my p plus 3's cancel out. And then the other thing that cancels out is the 4 and the 8, which would leave me with 2. So 2 times 5 would leave me with 10. Okay, I got to distribute the 3 through. So I got 16 plus 3p plus 9 equals 10. Combine my like terms, so I got 3p and then 16 plus 9 is 25 equals 10. Subtract 25 from both sides. So I get 3p equals negative 15. I divide by 3 on both sides, and p equals negative 5. Last thing I have to do is I have to check my work. So does this answer make sense? So up here it says p cannot equal negative 3, but I got a negative 5. So yes, this answer absolutely works. Hopefully you did okay on it. Alright, here's the last one. Pause the video and you try. Okay, so we got x over 4 minus x equals 2 over x. First thing we have to do is we have to figure out where it's undefined. So there's nothing I can factor, so I'm going to go 4 minus x cannot equal 0. And then the other equation is x cannot equal 0. So if I clean this up, I'm going to subtract 4 on both sides. So I get negative x cannot equal negative 4. Then I'm going to divide by negative 1. And I get x cannot equal positive 4. So x cannot equal positive 4 and x cannot equal 0. Any other answer, good as gold. Alright, next thing I gotta do is I gotta figure out what my LCD is. So They don't have anything in common, so it's just going to be x times 4 minus x. Alright, so I take that LCD and I multiply it by each rational expression, so I got x times 4 minus x over x times 4 minus x equals x times 4 minus x times 2 over x, and I put my LCD over 1 so I can cross cancel easier. So I got x minus 4, which cross cancels. So now I just got x times x, so that would be x squared. The x's cancel here, so I'm left with 2 times 4 minus x. And I know that I'm going to have to solve this. So I'm going to distribute the 2 to both sides. So I got x squared equals 8 minus 2x. Because I have a quadratic, this is going to bring me back to section 6.5. I got to move everything over to set it equal to 0, so I'm going to subtract 8, and I'm going to add 2x on both sides. So I've got x squared plus 2x minus 8 equals 0. I'm putting it in the x squared plus bx plus c form. Okay. Now that I've done this, I have 3 terms, so it's either an a equals 1, a doesn't equal 1, or it is a perfect square trinomial. This is an a equals 1. So I set up my parentheses. I go x, plus minus, factors of 8, 1 and 8, 2 and 4. I have to use subtraction in order to get to my b, which is 2. So 4 minus 2 equals 0. I split them up, so x plus 4 equals 0, x minus 2 equals 0, subtract 4. So x equals negative 4, add 2, x equals positive 2. I go and I check to see if these answers make sense. As long as it doesn't equal a positive 4 or a 0, I'm good to go. So this negative 4 is a-okay, and this 2 absolutely works as well. Alright guys, this concept is super important. It puts everything together, and you are expected to know this when you get to college algebra. So please go take the time now to go do your 7.6 homework. If you have any questions, make sure you bring them to class so that we can work together through them. Thank you.